Hi everyone, welcome to Easy Math. In this video, we are going to see class 8, chapter 1, exercise 1.4, that is the find squares and square roots, in which we are going to continue with question number 8. So let us read the question number 8 first. Find the square root of the following decimal numbers and fractions. So in the previous sums, we have been finding the square roots of whole numbers. See, like this 1764, all these are whole numbers. Now look at this sum, it is decimal number. These first three sums are decimal numbers with the decimal point, and fourth and fifth sums are rational numbers. Okay, they are maybe fractions. If they are positive, we can call them as fractions or rational numbers. So we'll take up one by one. First one is 2.89. Now, here should be very careful. What the first thing we did, if you can remember, we have to split them into periods. In one period, we have two digits. Okay. So, here we have to divide the periods for the whole numbers. Whole numbers is the numbers before the point. Before the point, we have to put the period separately, and after the point, we have to put the periods separately. So after the point, you have to start from the number just after the point. And same way, before the point also start from the number just before the point. So just after the point, 8 and 9 is one period, and 2 is before the point, whole number one period. Suppose if you're having the number like this, 22.8 we say. And when you are finding it, you cannot put like this, starting from one's place 8 and 2 and 2. No, this is the wrong way of, we cannot divide the periods like this, because there is a decimal point. If there is no decimal point, if it is 228, okay, from one's place 8 and 2 and 2, because 228 is a whole number. We can start it from one's place. We have to divide like this. We have to split it like this into periods. But here, when there is a decimal number, when there is a decimal point, we cannot combine from this. This is actually 10th place. We cannot state from 8 and 2. This is wrong way of splitting into periods. The correct way is after the point separately and before the point separately. And after the point, every period should have two numbers. If there is only one number, then we put 0. And still the value is not changed, because after the point, at the end of a number, when you add zeros, it has no value in a decimal number. 22.80 is same as 22.8. For that reason only, we start splitting the periods from just after the point, the first digit after the point and the first digit before the point. So if you split like that here, after the point 8 and 9, and before the point only 2. I told you to start with, in a period you can have one number also. But after from second period, third period onwards, in every period you should have two numbers. Okay, now the method is just the same as we did for the whole numbers. Only thing is, we have to keep a point in the quotient. Now for 2, if you start this square tables, 1 ones are 1, 2 twos are 4, but we have only 2. So 1 ones are 1, here 1, here 1, 1 ones are 1. 2 minus 1 is 1. Subtraction is over. Now, what to do? Multiply the quotient by 2. 2, 1 into 2 is 2. Write it here to the left hand side of the second line. Now, next, we have to bring down the next period. How many digits in each period? 2 digits. We have to bring down 2 digits. But those 2 digits, the next period is after the point. So keep a point in the quotient and bring down. It is just the division of decimal number, just like the division of decimal numbers. Whenever you take the number after the point, you keep the point in the quotient and bring down. Otherwise, the procedure is same as finding the square root of whole numbers. Okay, what is the next step? With 2, we have to put a number here and multiply by the same number. And it is a perfect square. So it ends with 9. So we should think of a square table which ends with 9. Yes, we know 3 3s are 9. So with this number 2, we'll put 3 and multiply by 3 and check whether you are getting 189. 3 3s are 9, 3 2s are 6. No, we are getting only 69. So with this 2, which is the next square table which ends with 9? If you can think of 1 1s are 2 2s are 3 3s are 4 4s are 5 5s are. Yes, it is 7 7s are 49, ends with 9. We want a number ending with 9. So this is a clue to find the number in an easy way. Okay, quickly, to find it quickly. So it ends with 9. So let us try with 7. So with 2, if you put 7, we have to multiply by the same 7. Now multiply and check whether we are getting 189. 7 sevens are 49. Carry 4. 2 sevens are 14. 14 plus 4 is 18. Yes, so the number we needed is 7. The next quotient is 7 here and 7 here. When you multiply 27 into 7, we are getting 189. So the remainder is 0. Therefore, root of 2.89 is equal to 1.7 is our answer. Okay. Next is 67.24. How to split them into periods. Just after the point, start from the first number after the point. 2 and 4 is 1 period. Before the point, same way, 7 and 6, 1 period. Okay, there are 2 periods. So in the quotient, you will have 2 digits. So till 67 comes, square tables, 1 ones are, 2 twos are, 3 threes are. We are getting 8 eights are 64 and 9 nines are 81. So which number will you write? We don't have exact 67, but you should go for the number which is less than 67, at the same time nearest to 67. So it is 8 and 8. Where will you write? Quotient 1 8 and the left hand side 1 8. 8 eights are 64. Now subtract 7 minus 4 3, 6 minus 6 is 0. Next step, quotient into 2. 8 twos are 16. Straight to the left hand side of the second step. Then bring down the next period. But the next period is after the point. So what to do? Keep a point in the quotient and bring down. Keep a point in the quotient and then you bring down the next 2 digits. That is the next period. Now with 16, you put a number, multiply by the same number, you should get 324. This number itself we have to get because it is given the question itself, they are perfect squares. So let us think of the square table which ends with 4. Yes, we know 2 2s are 4. So with 16, let us put 2 and multiply by 2. Check, 2 2s are 4, 2 6 are 12, carry 1 and 324 we are getting. Are we getting? 2 2s are 4, 2 6 are 12, carry 1, 2 1s are 2, 2 plus 3, 2 plus 1, 3, 324 we got. So what is the quotient? 2 and 2. We are getting 324. So remainder is 0. Therefore, what is the final answer? Square root of 67.24 is equal to 8.2. And how do you check your answer here, children? Yes, you multiply 8.2 into 8.2. How to multiply decimal number? We take out the point, multiply. After multiplying, it is 8.2 into 8.2. So here 1 digit, here 1 digit. We count 2 digits and keep the point. So when you multiply and check whether you are getting 67.24. Definitely you will get, you check it for yourself. Okay. Next is 2.0164. Yes, divide them, split them into periods. After the point, 0 and 1, 6 and 4. And before the point, only 2 is there. Okay, come on quickly. Square tables. Yes, now we are familiar. 1 ones are 1. Subtract 1. Next step, quotient, whatever number you have in the quotient, that into 2, always into 2 only. 1 2s are 2, write straight to 1 on the left hand side. You leave a gap here because we are going to fill it with the number. Next, bring down the next period. Next period is after the point. So keep a point and keep a point in the quotient and bring down the next period. Now with this 2, we have to put a number and multiply. And your answer should be less than this 101. See, this is not the last number. We have one more period to bring down. So we won't get the exact number here. So let us try. See, 2 and 101. The difference is too big. So let us try by 4. Shall we check? With the 2, you put 4 and multiply by 4. 4 4s are 16. Carry 1. 4 2s are 8. 8 plus 1, 9. Yes, it is nearest to 101. But still it is less than that. Let us check with the next number 5 also and see what we are getting. 5 5s are 25, carry 2, 5 2s are 10 plus 2, 125 is more than 101. So which one number will you write? 96 and the quotient is 4 for 0 1. For the period 0 1, the quotient is 4. You write the quotient straight above each period. Above 2, the quotient is 1. Above the decimal point, you also keep the decimal point. And above this period 0 1, the quotient is 4 and here 4. And 24 into 4, 96. Where will you write 96? Shall we write here 9 and 6? No, from one's place, 6 and 9. Okay. Now be careful when you're doing these things. We should not make any simple, silly mistakes. So from 1 we cannot cut. Borrow from here. 10, borrow. 11 minus 6 is 5. And what remains here? If you borrow 1, 9 minus 9 is 0. So it's only 5. So bring down the next period. That is 64. And what should we do here? Now whatever you have in the quotient into 2. 14 into 2 is multiply 14 into 2. Don't leave out the points. Just take it as 14 into 2 is 28. Now with 28, you have to put a number here and the same with whatever number you put, multiply by the same number. You have to get 564. So what shall we do? The number ends with 4. So which square table ends with 4? 2 2s are 4. So let us try with 2. 2 2s are 4. 2 8s are 16. Carry 1. 2 2s are 4. 4 plus 1 5. Are we getting 564? So we got the number. Next quotient is 2. Right straight above 64. Here 2. We got 564. That is 0. Therefore, square root of 2.01640164 is equal to 1.42. Okay. Next is find the square root of a fraction it is. So we have to find the square root of the numerator and find the square root of the denominator. That is your answer. See, this is just there in the square table itself. We know if you learn the square table from 1 to 20, it is 12 12s are 144. So square root of this is, we'll split them first. Square root of numerator divided by square root of denominator. This property also we have studied. That is root of a by b is equal to root of a by root of b. We can split the root for the numerator and denominator. So root of 144 by root of 225. This we know by heart because we know the tables, square tables from 1 to 20. 12 12s are 144, 15 15s are 225. Therefore, root of 144 by 225 is 12 by 15. So directly we can write as we know the square tables. So let us move on to question number 5, which is 718 by 49. What fraction is this? It's a mixed fraction. So first thing we have to convert into improper. What to do? Multiply denominator into the whole number and add with 18. Okay. So multiply them. Multiply 49 into 7. 7 9s are 63. 28 plus 6 is 34 and multiply 49 into 7, add with 18. And this is we are getting, so multiply 49 into 7, add with the numerator 18, we get 361. So that 361 is your numerator, same 49 is the denominator. So root of mixed fraction is equal to root of improper. This we can split for the numerator, split the square root for the numerator and denominator. Now what is this? We know 361 also we know because we know the square root square table still 20. So 19 19s are 361, 7 7s are 49. That's all. See how simple the answer is if you thorough with the square tables. So let us go to the next question number 9. Find the least number that must be subtracted to 6666 so that it becomes a perfect square. Also, find the square root of the perfect square thus obtained. Here, the 6666 is not a perfect square. From here, we have to subtract a number as a least number, the smallest number. We have to subtract some number from here so that this becomes a perfect square. So, we have to find a number which has to be subtracted from here so that this becomes a perfect square. So when it is what should be subtracted or what should be added, if that is the question, then you have to find the square root using long division method. That what we have been doing so far. And look at the next question. By which number this 1800 should be multiplied? If the question is to be multiplied or to be divided, then we have to use prime factorization method. These two things you should remember always. What should be added? What should be subtracted? To make a perfect square means it is long division method. What should be multiplied and what should be divided to get a perfect square means it is prime factorization, that is L division method. Okay. Now here subtracted, we will follow long division method for 6666. So the number is 6666. It's a long division method and it is a whole number. So from where will you start splitting into periods? From ones place. There is no point. So from ones place, 6 and 6, 6 and 6. Now till 66 comes, we should tell square tables. Yes, we know it is 8 8s are 64. When you subtract, we get 2. What's the next step? The quotient 8 into 2 is 16. Then bring down the next period 66. Now with 16, we have to put some number, multiply by the same number. Because it is not a perfect square, we know. We won't get 266 exactly. We will get a number less than that only. So let us try with 4 and 4. 4 fours are 16, carry 1. 6 fours are 25, plus 24 plus 1, 25, carry 2. 4 ones are 4, 46. Oh my god, we are getting such a big number. So we'll go for 4 times very big. We'll multiply with 2. With 16, add 2 and put 2. What do you get? 2 2s are 4, 2 6 are 12. Again, we are getting 324. So what is the next smallest number? 1 only. With 16, see here 16, we have third number, we are writing 1, then multiply by the same 1. So we get 161. So 2 times itself is greater than this. So it goes only 1. So quotient is 1 and here also 1, 161. Now subtract. 6 minus 1 is 5. 6 minus 6, 0. 2 minus 1 is 1. Now there is no next number to bring down. This is the remainder. If this remainder becomes 0, then we say it is a perfect square. How to make this remainder 0? This 105 should become 0. That means this number should be 105 less than this. Instead of this 105, instead of 266, if you should have here also 161. Instead of 266, we should have here 161. So what number? 105 is extra we have here. We have 105 more than the number we need. So what has to be subtracted means finally whatever remainder you are getting, that has to be subtracted. Because if you want the remainder to be 0, this 105 has to be subtracted from the given number. So you should write 105 must be subtracted from 6666. We want to make the remainder 0. So we have to subtract the remainder. What has to be subtracted? Whatever remainder you are getting, that has to be subtracted from the given number. So subtract from 6666. You subtract 105. We get 6561. Now find the square root of that and check whether it is a perfect square or not. Same way, split them into periods. We can copy the previous one here. It is 8 8s are 64 and subtract, it is 1. Then multiply 8 into 2, it is 16. Bring down the next period 61. See, with 16, what number you have to put to get 161? 1 and multiply by 1. So we get 161. So 1 here, 1 here. 161, we got the remainder 0. Therefore, root of 6561 is equal to 81. When it is 6666, it was not a perfect square. We had the remainder 105. When you subtract that remainder, we are getting 6561. That is a perfect square and whose square root is 81. Okay. The next question, question number 10. Find the least number by which 1800 should be multiplied so that it becomes a perfect square. Also find the square root of the perfect square thus obtained. So as I explained earlier, what should be multiplied means we should follow prime factorization method. 1800 is not a perfect square. So to make it a perfect square, we have to find a number by which this has to be multiplied. So for that, we use prime factorization method. So we follow the rules of prime factorization. You get a number ending with 0, you divide by 5. Till 18 comes, 5 3s are 15. After 15, 16, 17, 18. What is the remainder? 3. Carry with the next number. 30 becomes 5 6 are 30. There is no remainder. Next number 0 as it is. Now 360 again ending with 0, divide by 5. Till 36 comes 5 tables. 5 7s are 35. 5 7s are 35 means 7 is the quotient. After 35, 36. One remainder, it is 2. Now what is 72? Even number. Ending with 2 is an even number. Divide by 2. Till 7 comes 2 tables. 2 3s are 6. After 6, 7. One remainder. In 12, 2 6 are 12. 36 again. Even number. Divide by 2. 2 1s are 2. After 2, remainder 1. So it is 2 8s are 16. Now 18 is an even number. Again divide by 2. It is 9. 9 is a odd number. So divide by 3. It becomes 3 is a prime number. We can stop it. Now you write 1800 is equal to, what are we getting? 1800 is equal to, we get 5 into 5 into 2 into 2 into 2 into 3 into 3. So 2 5s and we have 3 2's and 2 3's. What is the meaning of square root? Square root means we take one factor for two same factors. These two 5's, 1 5. These two 2's, 1 2's. And these three 3's, 1 3. And this 2 is left. So to make it as a perfect square, with this 2 we need one more 2. Then only for 2 2's we can select 1 2. This 5 has a pair, 2 has a pair, 3 has a pair, but there is no pair for this. So to pair this we need one more 2. So this number, what is that extra number we need? 2 we need into 2. So therefore 1800 has to be multiplied by 2. So as there is no pair for this 2, if there is one more 2, then it becomes a perfect square. Therefore 1800 must be multiplied by 2 to get a perfect square. So when you multiply 1800 by 2, you get 200, 200, 2 8s are 16, carry 1, 3600 we are getting. So 3600 is equal to, for 2 5's 1 5, for 2 2's 1 2, and these 2 2's 1 2, and these 2 3's 1 3. So multiply, 5 2's are 10, 10 2's are 20, 5 2's are 10. 10 2's are 20, 23's are 60. So 1800 was not a perfect square. So it has to be multiplied by one more 2. When you multiply, we are getting 3600. So you need not do the prime factorization once again. We have all the factors and we have multiplied by 2. Just one more 2. You write within the prime factorization itself. Now we can select one factor for two same factors. Select 1 5, 1 2 and 2 and 3. Multiply, we get 60, and 60 is the square root of 3600. So with this, we'll stop this video, and rest of the sums we'll do it in the next video. Thank you all for watching. Thank you, children.